Alright, this video will continue on with the bottom flap of section number 4. We have found two shortcuts for proving that two triangles are similar. We learned AA, or two angles being congruent, proves two triangles are similar. We just learned on this flap that if the three sides of one triangle are proportional to the three sides of another, then the triangles must be similar. And we also have one more we're going to learn, and that is SAS, which class is also a proof of congruence. But for SAS similarity, if two sides of one triangle are proportional to two sides of another triangle, and the included angles are congruent, then the triangles must be similar. So let's take a look at an example of this. Let's go ahead and label the vertices of this so we know which angles we're talking about. I'm going to label this as A, B, C. If you ever have these on a test class, you can label the vertices whatever you want as long as you don't duplicate a letter. This is D, E, F. And again, you always want to be careful when the triangles don't match up exactly. If they're rotated or reflected, sometimes you might guess which sides or which angles go together, but you got to be careful. Do not guess. There's a way to figure it out. And the way we figured it out is we're going to take a look at the side measures. In this case, we only have two sides of each triangle, but we're going to use the same strategy we used for side, side, side. We're going to circle the bigger sides, and we're going to put a square around the smaller sides. So let's circle the biggest side of triangle ABC, which is 24. We're going to circle the biggest side of DEF, which is 32. Let's go ahead now and put a square around the smaller of the two. Notice your brain wants to tell you that the 24s match up, but they don't actually match up because the 24 is the largest side here and the smallest side here. Now let's go ahead and check and see if those matched up sides are proportional. So I'm going to go ahead and just pick 24 from triangle ABC, and I'm going to put it over the corresponding side, which is 32. That reduces down. This is both divisible by 8. We can reduce that down to 3/4. And if you want to convert that to a decimal, it's okay to do that as long as it comes out to a nice clean decimal. It's not a repeating decimal. Actually, in this case, I'm going to leave this as a fraction. Let's go ahead now and compare the smaller of the two sides. Remember, if I picked 24 from ABC, the top of my next ratio also has to be from ABC. So that's going to be 18, and that's going to match up to 24. Class, if you don't do that, you're going to prove that two triangles are not similar when they are. So 18 and 24 both come from the same triangle. 32 and 24 come from the same triangle. If we reduce those are both divisible by 6. 18 divided by 6 is 3. 24 divided by 6 is 4. And we have these two sides are proportional. Now side angle side similarity says all we got to do now is prove that the included angle, which is the angle in between those two proportional sides, if that angle is congruent, then we have similar triangles. We can see right now that means we see that angle A is definitely congruent to angle F. So now we've got side, angle, side, and now we can say just like over here, so the triangles are similar, we can write over here. So the triangles are similar. And notice, class, this is a shortcut because otherwise we would have had to check the other two angles and the third side. Well, we can't do that here because we don't know any measure of the third side, and we clearly don't know what the measure of the other two angles are. But I can definitely tell you that the other side is proportional, and the other two angles on the one triangle definitely are congruent to the other two angles of the other one because we know the two triangles are similar. All right, let's apply this to a problem. The question is, are these triangles similar? Alright, well, I can tell you, they don't look similar, but you never want to take that guess because who knows whether the person who was drawing the triangles did them accurately or not. So let's go ahead and check our side. Let's match up the largest side of this triangle to the largest side of this triangle, and we'll match up the other side we know, which is 8 on this triangle and 12 on this triangle. Let's go ahead and check our proportions. I'm going to go ahead and pick a proportionality. Sorry. Let's go ahead and pick 16 on the first triangle, which matches up to 24 on the second triangle. 16 divided by 8 is 2. 24 divided by 8 is 3. So you've got a 2 to 3 ratio, or a 2/3 proportion. Let's now go back to our original. We had 16 here, so we've got to use the side from the same triangle here. It's going to be 8. 8 over 12. 8 divided by 4 is 2. 12 divided by 4 is 3. So you can see, class, those two sides, they are proportional. So we're almost there. We need to check the included angle. Now, you might look at this and go, okay, 94 is good, 94 is good, boom, similar triangles, but take a look. This is the included angle of the first triangle, but 94 is not the included angle of the second triangle. Angle F would be the included angle. So even if we have two sides that are proportional and two angles that are congruent, if it's not the included angle, you cannot prove similarity. So the way you would write this out is, okay, we've got this. So we've got side and side, but angle E, angle E, which is 94 degrees, is not the included angle. Angle E is not the included angle. So now, class, we can't say they aren't similar, we just can't say they are. So if angle E is not the included angle, so we cannot prove they are similar. Let's say we prove they are similar by SAS. We also can't use side, side, side because we don't know the third side. And we also can't use angle, angle because we don't know either of the other two angles of these triangles. So sometimes you use these shortcuts to say, you know what, we don't have enough information to prove whether they are similar or not. So we've got AA similarity, SSS similarity, and now we have a shortcut called SAS to prove whether two triangles are similar, or maybe there's not enough information for us to use it to prove they are similar.